Happy Tuesday or Wednesday, whenever you're watching this, ladies and gentlemen. We are going to jump into Math 7 Unit 1, Lesson 3b. Kings and Queens, this is a little bit different because we usually watch these videos in class. However, you're doing this during your asynchronous time, mainly because we're a little bit behind and we wanted to catch up. Remember, guys, it's important that you're showing up to class on time so that we can start our lessons on time. It's also important that you're doing your work because we're not going to continue to accept so much late work. So this is your Wednesday independent assignment that is expected to be completed by the end of the day at 11:59 p.m. You guys are going to watch this video and also complete the student companion that is associated with it. But we'll dive more into that as we go. So for today's materials, again, these materials are important. You're going to need your Math 7 Spiral notebook, even though we're not in a live Zoom. You're still going to need your pencil, and then you're also going to need the student companion that's going to be found in Google Classroom. Now, the student companion is also listed with this entire assignment. So all of the things that you'll need for this independent time or asynchronous session is all in the same post. So make sure that you find today's student companion in Google Classroom. And then you're also going to put all of our notes today in your journal, and we're going to label it 9/22, September 22nd, and we're going to label it page 6 at the bottom of our notebook. So we're going to jump right into representing proportional relationships with tables. Once again, we're in day 2 of our lesson, still talking about constants of proportionality. So for today, the first thing that we're going to copy down is our standard. Our standard is 7.rp.2a and 7.rp.2b. And our objectives are as follows. Students will compare, contrast, and critique orally and in writing different ways to express the constant of proportionality for a relationship. You guys will also explain orally how to determine the constant of proportionality for a proportional relationship represented in a table. And lastly, interpret the constant of proportionality for a relationship in the context of constant speed. Our mathematical practices for this specific lesson are going to be MP2, MP6, and MP7. Again, remember to be ready to take notes. And because we're doing this independently, there won't be that much collaborative work. So, kings and queens, go ahead and pause the video here so that you can copy down the standard and objective into your journals on page 6. All right, let's jump right into our engagement activity for today. So our engagement activity says that we're going to talk about equal measures, and we'll take about 5 minutes. Well, I don't want you to spend too much time on your own going over this, but it says I will give you a long list of numbers and units, which I'll do in a second, and your responsibility is to record as many equivalent measures as you can. You can reuse numbers and units more than once. For example, if I give you the numbers 30 and 1/2, you can tell me that 30 minutes is equal to a half an hour. So 30 minutes is 1/2 hour. So again, you're going to record as many equivalent measurements as you can. And like I said, you can reuse any numbers possible. So let's jump into our list of equal measures. So here is a large group of different numbers that we can use. It says use the numbers and units from the list to find as many equivalent measures as you can. For example, you might write 30 minutes is 1/2 hour. So you can use the numbers and the units more than once. So on the left-hand side, you have a bunch of numbers, and then on the right-hand side, you have units of measure. So let's pause the video for about 3 minutes, just see how many you can jot down. So there were a number of different possibilities that you could have came up with. Some of you guys may have said that 1 centimeter is 0.01 meters, or a half hour is 30 minutes, 1 hour is 60 minutes, 1/5 of an hour is 12 minutes. You might have said 12 inches is a foot, 6 inches is a half of a foot. There are a number of different possibilities that you could have came up with. Now, let's just keep going. So if we were in class, of course, we would share out and star the ones that you heard that are the same as yours. And then if we were in class, I would have had you guys in the chat write how many did you have in class with your classmates? How many did you have in common with your classmates? And if you had anything different, we would have been able to share out. So let's jump into our goals for today's class. These goals are what we want to be able to accomplish by the end of our independent session time. So the first thing is we want to be able to find missing information in a proportional relationship using a table. And then we want to be able to find the constant of proportionality from the information given in a table. So let's jump right in. Let's look at how centimeters and actually, let's look and solve more problems involving proportional relationships using tables as a continuation of what we've been doing. So this is our elaboration activity. So for our elaboration activity, you are going to need your student companion. So once again, you are going to need your student companion. So we'll jump right into that. And we're going to be talking about centimeters and millimeters. So now let's look at how centimeters and millimeters are related and how it is related to what we've been doing recently. Okay, so the first thing that you should also see in your student companion is on page 2 is some information about proportional relationships. So as you can see on the slide and also in your student companion, there is a proportional relationship between any length measured in centimeters and the same length measured in millimeters. So for instance, if you look at this ruler that's again represented in the student companion, which you should have open at this point. Again, I'm going to keep saying that because I want to make sure that you're getting credit for this assignment. The only way to get credit is if you're actually completing the student companion that can be found in Google Classroom for this particular lesson and after you submit it. But again, if I'm looking at the student companion or at this slide, you'll see this ruler. The top part of the ruler represents centimeters and the bottom half represents millimeters. And if you look, you'll notice that 0 centimeters is the same as 0 millimeters. Obviously, if I have 1 centimeter, it's equivalent to 10 millimeters. 2 centimeters is equivalent to 20 millimeters. 3 is equivalent to 30 millimeters. 4 centimeters is equivalent to 40 millimeters. And 5 centimeters is equivalent to 5 centimeters is equivalent to 50 millimeters. So let's begin working on your own for about 3 minutes in your student companion. So you can pause the video here and see if you can answer those first 2 questions. And let's see what we can do. All right, now, so let's go ahead and check some of our work. So the first part of the student companion asks you to complete the table, and we need to determine what the constant of proportionality is. So based off of our ruler from the previous page and also in our student companion, we know that everything essentially has been multiplied by 10. 1 times 10 gave me 10, 2 times 10 gave me 20, 3 times 10 gave me 30, and that's how we can find the comparison. So if I'm doing that same thing to complete my table, 9 centimeters would be equivalent to 90 millimeters. So that would be the first blank in my table. 12.5, if I multiply that by 10, I should get 125 millimeters. 50 centimeters would be equivalent to 500 millimeters. And because we're checking this and I want to make sure that you're completing your work, I'm not going to go over this last one, but if I were to multiply 88 and 49 hundredths by 10, what would my equivalent be in millimeters? So again, go ahead and answer that one because those will be one of the problems that we check when we are submitting the student companion. And then once again, question 1B in your student companion asked you, what is the constant of proportionality? And we kind of already spoke about it. You should have realized that the constant of proportionality was 10 because again, that was our unit rate okay, 1 centimeter for 10 millimeters, and that was also the number that we multiplied by. So again, that unit rate, 1 centimeter for 10 millimeters, that's our constant of proportionality, okay? Let's keep going. So we want to sit here and think about how are these two constants of proportionality related to each other? So let's figure out how we can do this. So to convert from centimeters to millimeters, you can multiply by what? We just kind of talked about it. To go from 1 centimeter to 10 millimeters or 2 centimeters to 20 millimeters, we can multiply by the number 10, right? And then to convert from millimeters to centimeters, to go the opposite way, we can divide by 10, or you can multiply by 1/10. Remembering dividing or multiplying by a fraction is the same thing. So let's make sure that we copy this slide down. So if you need to pause the video here, you can do so, but let's copy this down in our journals on page 6. And once again, to convert from centimeters to millimeters, you can multiply by 10. To convert from millimeters to centimeters, you can divide by 10 or multiply by 1/10. So again, pause the video here so that you can go ahead and finish copying this down. Now that you've copied this down, you'll realize that we also need to make sure that we fill these blanks in on your student companion. So on the same page, page 2 of your student companion, number 4, please make sure that you complete those blanks that are there. And then for number 3 in the student companion, go ahead and tell us in your own words how they're related to each other. All right, moving right along. Let's jump into our next activity, talking about flying from Pittsburgh to Phoenix. Now, this is going to be an activity that's going to make connections between constant speed and proportional relationships, specifically paying attention to the constant of proportionality. So here we have a list of measurements: 4 miles, 8 miles, 20 miles, 2 miles, and a half a mile. So we know that someone walks at a constant speed of 4 miles per hour. So that means that if they're walking at a constant speed, they can walk a total of 4 miles for every hour that they're walking. And we want to know how much time does it take for them to walk all of these different distances. So hopefully you would notice if it takes me if I want to walk 4 miles, well, that was my given. I can do 4 miles in 1 hour. So that means I can do 8 miles in 2 hours. I could do 20 miles in 5 hours. Okay. 2 miles, because that's half of the original that was given. I can do that in a half an hour. And then a half a mile, well, that's not going to take me any time. I could do a half a mile in 15 minutes. So someone rides a bike at a constant speed. They go 30 miles in 2 hours. What is their speed? So hopefully you're realizing that the given is 30 miles in 2 hours, but to know their speed, we need to find the unit rate or the constant of proportionality, meaning that I want to know how much I can do in 1 hour, because remember the unit rate is per one, or the constant proportionality. We always want to look for the base, which is 1. So think to yourselves for 30 seconds, how much can they do in 1 hour? Hopefully, you realize that in 1 hour, they will be able to complete 15 miles. Now, once again, someone rides a bike at a constant speed. They go 30 miles in 2 hours. What was their speed? So let's see if we can compare the distance walked in miles and the elapsed time. And this is just a representation to show a double number line if you needed assistance figuring this out. But this is kind of combined the last two problems that we've done. So let's keep moving. So, on its way from New York to San Diego, a plane flew over Pittsburgh, St. Louis, Albuquerque, and Phoenix, traveling at a constant speed. Complete the table as you answer the questions and explain and show your reasoning. So, in your student companion, we want to be able to complete the table that's there. If you look, the first part that's there is there's a segment, there's a time listed, the distance, and then the speed. So, with that being said, let's be able to complete the table. So let's go ahead and answer some of these questions. The first question, after you've completed the table on the student companion, says, what is the distance between St. Louis and Albuquerque? Now, on the table, you might realize that it says the time that was elapsed was an hour and 42 minutes. So the distance would be 935 miles. You can do this because 42 minutes is 42 out of 60 when we talk about hours, because there are 60 minutes in an hour. That also simplifies to 7 over 10. So 7 over 10 of 550 is 385, and 385 plus 550 equals 935. Now, that might be really difficult to kind of imagine. So let's go ahead and copy down this statement that's in our notes. So for number one, 935 miles, 42 minutes, and you can go ahead and copy down that statement to kind of help you answer the student companion. Number two says, how many minutes did it take to fly between Albuquerque and Phoenix? This was also a part of your table. It would take 36 minutes. And the way that we got that is 330 is 3/5 of 550. So that means I just need to multiply 3/5 of 60 minutes is 36 minutes. And that's how we got that. And then last but not least, number three on my student companion that we're answering is, what is the proportional relationship represented by the table? So the relationship that's being represented is the distance traveled is proportional to the elapsed time. So again, we're comparing distance traveled to the time that has passed. So those are the answers to my three questions. Let's make sure that we can get this down in our student companions, because we want to make sure that you have this as a reference moving forward. So now let's keep moving. So, which quantities are in a proportional relationship and how do you know? Well, technically, all of these are in a proportional relationship because we're finding the equivalent distance to the elapsed time. And we know that based off of the calculations that we've been doing and are given of Pittsburgh to St. Louis. The next part that we need to talk about is, what is the constant proportionality in this case? Remember, constant proportionality is the same thing as your unit rate. So we're looking for where there's a base of 1 hour or 1. And in this case, our constant of proportionality is 1 hour for 550 miles, or if you wrote it 550 miles per hour. That is our constant of proportionality. So here again is just a vocabulary word wall. Again, at the end of the week, all of these will be posted in Google Classroom so that you can kind of keep all of this straight moving forward. So let's kind of recap some things really quickly. In the first activity, we examined the proportional relationship between millimeters and centimeters, right? We said 1 centimeter is equivalent to 10 millimeters. And then it said from two different perspectives and found two constants of proportionality. So what were they? We said 1 centimeter for 10 millimeters. So that's one of them. And then the other one would have just been the reverse of that, 10 millimeters for 1 centimeter. So what is the relationship between the two constants of proportionality? Hopefully you realize that 1 centimeter over 10 millimeters or 10 millimeters over 1 centimeter are just reciprocals of each other. And what does that mean? When we have reciprocals, that means that we just flip the individual fractions. So 1/10, the reciprocal of that would be 10 over 1. The reciprocal of 10 over 1 would be 1 over 10. So that's what we mean when we have two different constant proportionalities. Now, in the second activity that we did, we examined a proportional relationship between the time a plane flies and the distance that it travels. So in this one, what was the constant of proportionality in this task? We realized that for 1 hour, we could go 550 miles, or the reciprocal of that, in 550 miles, we could complete in 1 hour. So what does the constant of proportionality represent in terms of this context? We're just talking about the speed being traveled by the airplane. So once again, we're talking about the magnitude of speed. Now it's time for our wrap up, our exit ticket, the evaluation fish tank activity. So this activity is only 3 questions and should be a little bit easier. So what we want to do is go ahead and pause the video here. This is one that we'll be grading. Let's see if you guys can answer the evaluation task. I'll read the problem for you and then you can pause the video so you can complete it. It says, Mai is filling her fish tank. Water flows into the tank at a constant rate. Complete the table as you answer the questions. So if you look at this problem, you're going to complete the table and then answer the 3 questions. And then once you do that, you can continue the video. So once again, let's just recap over today's goals. So our goals for today were that I can find a missing information in a proportional relationship using a table. I can also find the constant of proportionality from the information given in a table. Okay, so those were our goals for today. I know this might have been a packed lesson also to do on your own. So I definitely want to make sure that you guys have a great rest of the day. But before you do so, let's make sure that we recap some things. Let's make sure that we're on time for class on Thursday. Remember, you need to be present in class on time. We also want to make sure that you are submitting all of your independent activities. So for today, because this was your independent activity, the only thing that you're responsible for is making sure that you submit the student companion. Please, please, please make sure that you submit the student companion because that is your grade for today. And last but not least, we want to make sure and remind us that we are in a global pandemic. But with that being said, even though we are at a distance, we still love you. And please make sure that you stay safe. If you have any questions in the meantime, please do not hesitate to email Mr. Spencer or Mr. Walker, and we will be sure to get back with you. We can't wait to see all of you guys on Thursday.